still raining. Okay, I found this article today, and of course it's from CNBC, but the title to the article is "The Real Reason for Disappearing Jobs Isn't Trade, It's Robots." So what CNBC has done, and a number of other people have done, is they've looked at Donald Trump's campaign right there. And the way Donald Trump got elected, in a large part, is that a good portion of American workers, which is the bread and butter of the U.S., just like in Malaysia, when you look at the average worker, we're not talking millionaires, we're talking about people that have had factory jobs or have had blue-collar jobs and have seen those jobs disappear over the last 30 years. And there's multiple reasons why those jobs have disappeared. The easiest one is that manufacturing in the U.S. is expensive. The reason it's expensive in the U.S. is because people are expensive, right there. So a lot of that early movement of jobs went overseas to places such as, if you go back 30 years ago, Malaysia was a prime target for a lot of the U.S. jobs. The Philippines were a prime target. Indonesia. More recently, China has become the prime target of a lot of the manufacturing out there. So those people are out of work out there, and they wanted a president that will promise them that they would get jobs equal to or better than the ones they had. These are the same type of people that don't want to go back to school and get retrained. These are people, and I've got a good friend of mine. I went to high school with him. He's the same age as I am. He just turned 60. Come on in out there. Let's see, we're going to take a roll call of how many people are late. Let me turn the camera on and out there. So, all right. For those who just came in, I'm talking politics, U.S. politics here. I don't know anything about Malaysian politics, and I don't want to get involved in Malaysian politics out there. I'm not allowed to vote in Malaysia. And, what's that? No. But I did vote in this election in the U.S. out there. So, but what Donald Trump did is he promised all these people that he would figure out a way to bring these jobs back. And when you look at politics and you look at the average voter in the U.S., now I would have to say it's probably true from my discussions in Malaysia that people don't look much farther than their own household. If I'm a 55-year-old, 60-year-old former factory worker who saw my company shut down their plant and move to Mexico, and I've been, and I lost my job that was paying $20+ an hour, and I'm now cleaning toilets at a public school for $8 an hour, I would love to see that job come back out there. And that's exactly what happened to this friend of mine, by the way, that I'm talking about. He worked for a company that made ovens for pizza parlors. Made the ovens for Pizza Hut and Domino's and companies out there. And these were all machine made in a factory in Fort Wayne, Indiana, where I used to live out there. And they paid their workers between $18 and $22 an hour out there. And they sold these pizza ovens, to various pizza parlors. Well, about 5 years ago, they shut that plant down and moved all those jobs to Mexico. Out there. So he's very upset at Bill Clinton, who was president when NAFTA was enacted. NAFTA was the North American Free Trade Agreement, which allowed that company to build pizza ovens in Mexico and sell them in the U.S. and not pay an import duty right there. So you've got this huge population of people that have lost jobs, and they blame it on free trade agreements. And the largest free trade agreement that the U.S. has suffered from has been called NAFTA, the North American Free Trade Agreement. Right now, Obama's been working on the Trans-Pacific, free trade agreement, which would do the same thing as NAFTA did, only this time it would bring in Malaysia, Singapore, the Philippines, Japan, everybody but China, up there, and allow companies to move to Malaysia and build. Come on in, that's there. You're not interrupted. That's there. So that was really one of the key things. It was a lot of it was about jobs right there. Donald Trump has made these promises. He's going to bring these jobs back. That's there. So people don't think beyond their own checkbook. That there. I mean, their own family budget, and they don't care whether he raped a 13-year-old girl back when he was running the Miss Teen USA pageant. They don't care whether or not he swindled a bunch of people out of billions of dollars when he, built Trump Towers and in Atlantic City. They don't care that he's had 3 trophy wives and about ready to dump his 3rd wife and get another younger model. That there, they don't care about that stuff because they're worried about having food to eat. So that there. So now, what the research is now showing is that the real loss of jobs in the U.S. has almost nothing to do with free trade agreements. The real reason for disappearing jobs isn't trade; it's robots. That's what they're coming out, and Donald Trump can't bring those back. So this is an opinion article, and I'm tying it in because first off, everybody sitting here in Malaysia go, why in the heck did they ever elect Donald Trump? That there. The guy's a complete idiot in most people's opinion, and he's not an idiot, but he's a sexist, racist buffoon that probably should not be president of the United States. That there. So, but he understood that people want jobs, and that's what he pushed. That there. Back about 6 months ago, Bill Clinton told Hillary's campaign that they need to start talking to the workers more, and they ignored him because after Hillary lost primary in Wisconsin, Bill picked up the fact that they're ignoring the working man, the factory workers, the bus drivers, the trash collectors, the people and that's usually the largest majority of the people in a country. There's only so many bosses, right? That there's only so many jobs for engineers, only so many jobs for doctors, lawyers, managers. Most of the jobs are done by workers, right there. You look at a construction project. Let's ignore whether or not they're foreign workers brought in from Indonesia or wherever. Let's just count bodies and assume that these are all voting people like they normally would be if you didn't have an immigrant, foreign worker program. That there, you didn't bring in foreign workers. That there. If you look at the construction of a new building, you've got probably a dozen engineers that laid it out, planned it. You've got several, construction managers that are there on site directing it, and you probably got 300 or 400, back-breaking construction workers that are lifting materials, operating cranes. That there. So the majority of these people are working people. So when you look at a country like the U.S. or Malaysia, the majority of the people are working people. That there. So that there, and of course, workers have the same number of votes as managers do. If you're an engineer, you don't get 5 votes versus a construction worker that gets 1 vote. And it's the same way here, right? That there. So he knew how to appeal to the workers. That there. Hillary's campaign ignored the workers. And of course, this is they call it the Monday night quarterback in the U.S., but after the fact, you can go back and see why he won and where he won, is that people who don't have jobs, who are making a third or a fourth of what they used to make, that's what they're going to vote on. That's it. So, this article basically says Donald Trump got elected in part by appealing to the blue collar and blaming the loss of jobs on immigration and bad trade deals with China. So in other words, that's what he claimed right there, is that the reason people don't have jobs is that illegal immigration and bad trade deals. And bad trade deals go back to, NAFTA is the one I mentioned because that's the one that my friend keeps bringing up because that's the one that cost him his job. But there's been others that the Trans-Pacific Trade Agreement that you've probably been reading about in the news here, that Malaysia's a little upset because Donald Trump doesn't support it and may be dead in the water. right there, and they've spent 5 years working on it. These are all deals that the American workers are looking at and saying, these are bad for us. They may be good for the country, but they're bad for me as a worker. I'm working at Ford Motor Company, and I'm building cars, and Ford is building a new plant in Mexico or Canada or Brazil, and they're going to put me out of work right there. Or India is now opening up a new call center, and they're going to close this call center here in the U.S. and move it to India. And again, I have a friend of mine that worked for United Airlines for 12 years, and they shut her down, the entire call center, they just shut it down, moved the whole operation to India, right there. So what he says is true in part, that a lot of these jobs have left the U.S. and gone elsewhere where they can change hire cheaper labor, right there. And that's a problem you've got whenever you've got an economy with an increasing cost of living, an increasing standard of living, an increasing wage. And that's kind of a warning factor, because that's one of the goals of the current administration here. Again, I say I'm Malaysian politics, but I'm just saying that when you do increase the cost of living, you do increase the cost of doing business, then some industries will choose to go elsewhere where it's cheaper. Japan suffered a lot of that in the 1960s. And you can tell that by looking around Malaysia and see the number of plants that have names such as Panasonic and Sony and, what's the other one? LG, not LG. LG is a Korean company. But you look at the number of Japanese companies that are building electronics in Malaysia. You don't think that they wouldn't rather build those in Japan and create jobs in Japan, right? But Japanese workers cost too much. Japanese land is too expensive to put factories on. So they build them elsewhere, right there. So as you increase the cost of doing business there and raise the standard of living, you also run the risk of running the jobs out. And the U.S. is one of the more expensive places to do business. And, and again, that comes back to the fact that as a lecturer in the U.S., I earn approximately 3 times the salaries I earn in Malaysia, right there, for doing the same job. Actually doing about 2/3 of the job right there. So, and I'm not complaining about what I'm being paid here, the work level. It's just I'm saying that when you look at the cost but education costs 3 times as much. If you're a student in an American university, a private university, you're going to pay, or a public university even, you're going to pay about 40,000 ringgits a year just tuition. That doesn't count any books or any living expenses. That's just for the right to attend class. So that's about 150,000 ringgits a year. That there. You're talking quite a bit of money that there. To go to school. Actually, the cost is about 15,000 USD plus other expenses, about 20,000. So you're probably talking about 100,000 ringgits a year. It's just to go to school in the U.S. Obviously, to send someone to the U.S. to go to school, and that's not counting living expenses again. That's not counting food. That's not counting rent or anything else. To send someone to the U.S. to go to school, you're talking approximately 40,000 USD a year, about 120,000, 150,000 Malaysian ringgits a year. You don't see too many. That's why they don't run exchange programs with the U.S. anymore. We talked about setting one up, and you look at the expenses, and it just doesn't work right there. So, but again, getting back to our article, is that he points out here in this article is that he ignored one key issue, and that's automation right there. We're not talking about we're not talking about technology, robots, automation in factories, but that's a big part of it out there. But again, we're talking about the fact that, if we look at manufacturing goods, it's been on a long-term decline for decades right there. So this is something that Donald Trump has not happened since Bill Clinton and NAFTA. In other words, this has been going on for many, many years right there. So now, when you go back here and you get down further in here, one study shows that 47% of U.S. jobs will be replaced by robots in the next 10 to 20 years. That's all, that's a big number. 47% of jobs are going to be replaced by robots. Donald Trump can't bring those back by canceling free trade agreements. Those are companies that are going in there and they're replacing the person on the assembly line with a piece of equipment that does the same work right there. They're replacing the driver in the cars with self-driving cars. Uber has done a lot of work in self-driving cars, and they've got taxis running around Philadelphia and various other cities in the world that don't have drivers in them anymore. In other words, the taxi comes, you swipe your ATM card or your debit card into it or your credit card, you put key in where you want to go. Actually, you say it into the robot where you want to go. It's got voice recognition. That there, it finds it on the map, shows it, confirms that that's the location, and it takes you there. There's not a person involved right there. They are now working on that there. So technological change disrupts labor markets, can hurt individuals whose skills are substituted by technology. That's there. Now, this gets back to what I was saying early in the semester, that when we look at the sociology, the economic effect of robots right there, is that this is a big key factor right there, is that people are screaming their jobs are disappearing. And Trump points to one factor, that's illegal immigration and or trade agreements allow that there. But the bigger factor is going to be technology and robots that there. As a result, these jobs aren't coming back that there. Now, the warning is those jobs are also going to leave here that there. That there. Now, there's a break-even point when you look at robotics and automation that there, and find my pen here to kind of talk about that a little bit, is that when we look at the cost, let's say, for example, it costs this much to have a person do the job, right? And it costs this much to have the robot do the job. And my pen has done its thing again. I think right there. Here's the cost of the robot doing the job. It's that much cheaper right there. But the cost of the robot is this right here. Now, that's what it costs you to buy the robot. So, so right now the cost of, say, doing business, I'm just going to put a formula down, is it costs Y equals, and I'm going to say the cost of labor times the number of units right there. Right there. So that's the cost of doing it with a, doing it with a person. In other words, it costs you so much that there. X is equal to the cost of the robot, R, that's a fixed cost, a one-time cost, plus B times T, number of units up there. So when we look at the cost of the robot, how long does it take before that robot pays for itself? Right there. Now, if A isn't big, it's relatively small, it takes a lot longer for that robot to pay for itself. So if you're talking to a company like, or a country like Indonesia, where you're paying someone the equivalent of $5 a day, then it may not be worth it to buy the robot because it's going to take you 20 years to pay for the robot. But if you're looking at a country like the U.S. where you're paying the person $150 a day, right there, which is not an unusual amount. $150 is, if you look at, 150 divided by 8 equals $18.75. What did I say they were paying my friend to make pizza ovens? Between $18 and $22 an hour. So an average worker, $150 a day U.S. is not that unusual. We're talking skilled, unionized factory workers right there. We're not talking about somebody flipping burgers at McDonald's. Right there. We're talking somebody that's working in a factory in a skilled job, making $20 an hour is not unheard of. Right there. So when you look at this here, then all of a sudden, this payback is within a year or two, that worker's gone. And the robot's now replaced it right there. So that's when you look at low-cost labor versus high-cost labor, and the rate in which you accelerate the move to technology has a lot to do with the cost of labor that you're replacing. Because almost every robot that you put into operation is replacing a person. Now, there are some robots that are enabling technologies and new technologies. You know, like a drone that flies around and takes pictures and things like that. You know, that's something a person couldn't do. I mean, unless they got in a very expensive helicopter right there. And it's the same thing if you're sending a robot into a hazardous area to look for, casualties and things like that after a fire or an explosion or a building collapse. Again, you're talking something that you normally would not have a person do. But if you're talking on a factory line in automation, that robot's replacing somebody or somebody's. One robot can replace 5 or 6 people out there. Even if it's a one-person station, it's going to replace 4 if it's shift work. Because the average, if an operation is 24 hours a day, you have to have 4 workers to fill that position, right? Or at least 3. If they're working 8-hour days, 5 days a week, and you're shut down on Saturday, Sunday, or Thursday, Friday, depending where you're at in Malaysia, that's there. But you're replacing at least 3 people. And if it's a 7-day operation, you're probably replacing 4 people right there. So when you get into this whole discussion right there, and then they go into a little bit more. Currently, factory and office jobs are being phased out. One of the jobs that's been phased out by technology already in the office is, I remember way back when I first started working in the 1970s, we used to have what they call the typing pool in a company I worked with. And the typing pool was a group of about 5 to 10 young ladies that worked for this company. And all they did was, executives would walk in with their handwritten notes and things like that, and they would type these up into letters to be mailed out or whatever. This was all done in the typing pool, right? So you got, again, it was 5 to 10 young ladies. Normally, I don't think I ever seen any guys back in the 70s working in the typing pool there. And, and that was a big, that job existed since the 1940s right there. Nobody has a typing pool anymore. Why? Everybody's got a word processor on their desk. You don't send something to the typist to type it up. It's so easy to do on your word processor that you don't write it by hand. You do it there. It corrects your spelling. It puts it in the right format. You might forward it to a secretary or somebody in the office to clean it up for you, but you don't have a typing pool anymore. Those office jobs are gone. It's been replaced by a computer, right? Right there. So we're looking at the fact that a lot of these jobs are being phased out right there. So again, other particular, I haven't seen it in Malaysia, but in the U.S., people scan and bag their own groceries in most grocery stores. They have that self-checkout lane right there. And you go up to the checkout lane, and you got your cart, and you take your groceries one at a time. You scan it over the scanner just like the cashiers do here, and you put it in the bag yourself. And of course, they have cameras staring at everybody, make sure no one's stealing like crazy, right there. So the loss prevention departments have grown a little bit, but again, you've replaced 5 or 6 cashiers with one loss prevention person, and then every now and then somebody will come by and look at your ticket and then check the items in your bag and make sure that you have something didn't go in there you didn't pay for. But you've replaced the cashiers. The cashiers are gone now. Along with the baggers. I mean, it's all done yourself. Now they're talking about putting RFID chips, which is a little chip, in each item in your cart, and you walk underneath the scanner as you walk out of the grocery store. You don't even go through a cashier right there. It scans your cart and then tells you what you owe. That there, and then you go off and you bag it yourself. Or you just push out the car and put it in the boxes in your car. There's not a cashier involved, but everything in that cart is got a tag on it, and it will be automatically charged, that there. So again, you're eliminating people with automation. So it's just not robotics right there. So again, we look at it right here. This is an interesting discussion item right here. San Francisco has built a robot that can make a hamburger from scratch. So now you can replace cooks with a robot. Now every housewife in the world would probably want to have that robot, right? That there. That there. And again, notice that it says the technology is more sanitary and faster than human cooks. Right there. And the one thing that robots are that humans aren't is they're consistent. Now, how many people buy Ramley burgers from the little stalls that there? I mean, I buy them from time to time out there. Okay. And everyone has their little favorite Ramley burger stall right there. Everyone's got their, my wife says, this guy's not nice. This, that. They're the same freaking burgers sold by Ramley. They're the same buns. They're the same sauces. But somehow this guy makes his taste better than this guy does. Maybe he has to grill a little bit hotter. He uses a little bit more butter. Maybe he puts in a little bit more of the chili sauce than the tomato sauce. Maybe but they have all these little tricks that make them, even though it's the same raw ingredients, it's the same grill, it's the same propane burner underneath the flat top, right? And yet, they all taste a little bit different from each other out there. So I'm not saying that the differences are just in your head. There are real differences out there, and I've tasted them. So I'm not out there. But the reason there's real differences is because two people don't cook exactly the same, right? Out there. My grandmother grew up in the hills of Kentucky. You talk about Kentucky Fried Chicken. I grew up on eating Kentucky Fried Chicken whenever I went to Grandma's house out there. So, out there, and we had real Kentucky Fried Chicken, and it tastes nothing like the garbage they sell at KFC. By the way, I eat KFC, but it tastes nothing like homemade that there. And of course, nobody cooks like Grandma because that's what you grew up with, and that's what you learn to taste that thing. So, but regardless, when you start putting robots in the kitchen to cook McDonald's burgers, they're all going to taste the same. Now, McDonald's has done one thing in life better than anyone else: is they instilled consistency. That there. I can go to McDonald's down here on John Gombach. I can go to the McDonald's there at KL Central. I can go to the McDonald's in Fort Wayne, Indiana. I can go to the McDonald's in London. And their Big Macs are all going to taste like a Big Mac. Right there. Nothing special about a Big Mac. I'm not saying that they're great or anything else. But McDonald's Big Macs taste the same no matter where you go. Right there. So, and that's what restaurants look for, is consistency. Right there. Mom and pop or local vendors, they look for that edge to make them different. Because, let's face it, there's probably 10,000 Ramley burger stalls in KL, right? And if they all taste exactly the same, half of them would disappear. Right there. And only the ones in real convenient locations, or the ones that are willing to charge a little bit less, are going to survive. Right there. But the reason that a lot of these little small guys, succeed is that they manage to have they have a following of people that go to them. We've got our favorite place about 3 blocks from the house. I'll get on the bike and ride over to it and get the hamburgers, and I'll go buy 2 more to get to it. Right there. We've got one a block from our house. I ride right by that one. I got another one 2 blocks from the house. I ride right by that one to go to the one we always go to. Yeah, same hamburgers, same buns, same sauces, same grill, right there, and same price. And yet I pass 2 different ones to go to our favorite one, right there. So, so that inconsistency is a good thing, but it's not necessarily a good thing in the restaurant business. Again, TGI Fridays. You don't want I don't care. I'm going to pick up something, fish and chips. You go to TGI Fridays and you order fish and chips, right? And you want those fish and chips to taste exactly the same on Friday evening as they did on Tuesday afternoon. You don't want the fact that on Tuesday afternoon, Cook A was working, and Friday night, Cook B was working, and Cook B's is not to your taste. You want the ones that Cook A cooks out there because they taste better right there. So in the restaurant business, unless you're going to have the same cook all the time like you do on the burger places right there, you want the food to be consistent. You don't want someone coming in and asking, is Joe cooking today? I'm using Western names. Is Joe on the grill today? Out there. No, Mark's on the grill today. Well, then I don't want to eat that there. And and I've seen that happen in small pubs and things like that, especially in the U.S. Is that some cooks out there. But again, going back to right here is that the product is that there. So again, we're looking at there. So the rest of this kind of goes into this comment right here that this paragraph here makes an interesting argument. It's easier for people to blame other people, whether it's a worker in China or an immigrant, than to understand the intangible force. This is what Donald Trump really relied on, is the fact that it's easy for Americans to sit down and blame the Malaysians in Malaysia that have taken their jobs because they moved this chip factory from Houston, Texas to Kuala Lumpur. And by the way, there is a chip factory here in Kuala Lumpur that was moved from Houston, Texas, right there. It's in Carmel, AU, there, the Texas Instrument plant, right there. So it's easy for the guys in Texas to get upset about these Malaysians that stole their job, right there. Donald Trump mentioned Singapore particularly as one of the countries that steal jobs. And again, he was pointing to the IC factories that had moved to Singapore from the U.S., right there. And he looks at that there. So again, the rest of this kind of goes into that there. But it's just kind of points out here, and the last thing he brings up here is he's pointing to what they call guaranteed income in the U.S. That's his premise of this article. I'm picking and choosing the parts that that I think are important while we're studying. I'm ignoring his thesis there. So whenever you read an article, by the way, like this, they talk about here, Donald Trump got elected, he ignored. He finally ends up with his final statement here that he talks about guaranteed income, that people are guaranteed a basic income, whether they get jobs or not. So it's a very socialist idea. But what he's pointing out is that Trump's unexpected victory points out is the fact that people are getting frustrated in the fact that these jobs are going away, and it's causing some instability in the United States. So Trump is a symptom, a very bad result of what happened there. And you heard my opinion earlier on Trump. I'm not going to repeat it, but But he's a smart enough guy to point out that one of the things that Bill Clinton told Hillary's campaign many months ago is that she's ignoring the workers, that she needs to target states like Pennsylvania and Ohio and Indiana and Michigan and Wisconsin, Illinois, who've lost jobs, and she's going to have to give them something. And she completely ignored that and pushed how great the free trade agreements are for the country and how much money they're going to bring in. But she ignored what was going to happen to the workers. And it's these common workers is the ones that got Trump elected. Again, they didn't care about the other things. They cared about the fact that they lost jobs. So enough on that little discussion. Again, it's related to the topic, but it's one of those things is how did Trump get elected? And this is really one of the key facts And Hillary's inability to see the fact that she did not address that issue at all in her campaign. She spent most of her campaign talking about what a moron Trump was and she was right there. And totally missed the whole point is there's a whole bunch of people that are not happy and they don't have good jobs. And they want some kind of future because they don't see anything coming out of what's going on. All they see is it's going to get worse. And it probably is. When you look at if you look at that middle class that did factory work, those jobs are probably gone forever. In the U.S. especially. Those jobs are not coming back. So Those people need to get off their tails and get back to school and retrain to do something different. Or they have to figure out another way to adjust their lifestyle. But, the days of somebody working in a factory putting wheels on a car making more than a college professor or a nurse are over with. And trust me, I had neighbors when I first started teaching that made 50% more than I did, that had high school or less education, that worked in a factory, driving forklifts or working on the assembly line out there. They were making much more money than educated workers did out there. Those, that has gone away. Those jobs have disappeared because those jobs didn't need special skills. They can be moved overseas or they can be automated out there. I remember very distinctly having the conversation with my friend who worked for United Airlines, and she was bragging to me probably 15 years ago about how she was going to make more than $20 an hour within 5 years. And I looked at her, and my wife at the time punched me for saying it. Out there, I said, "Are you crazy?" She goes, "What do you mean? Are you crazy? They're going to pay somebody without any special training or skill or education $20+ an hour to take airline reservations over the phone." She goes, "Oh yeah. That company's going to be bankrupt within 5 years." And within 5 years, United Airlines filed bankruptcy. And her job was shut down and moved to India. So my prediction at that time was that they couldn't afford to keep that up. Nowadays, how many people know travel agents today? I mean, they're still popular in Malaysia. They're almost gone in the U.S. But travel agents, I can't remember the last time I used a travel agent. I used to use them a lot. It was very common. I'm getting ready to go someplace. The university had them on staff. They would call the travel agent, and they would book the tickets, the hotels, and all that. I get on my laptop or even my phone, and I go, all right, I want to go to Phuket for a week. Which airline's the cheapest? Which hotels? I start going, the hotel sites, Expedia, Booking, that there, and that there. So the travel agent is another job that technology has replaced. That there. There's still a number of it in Malaysia, but I guarantee you that's a job that will probably be gone in 5 to 10 years. My city in Fort Wayne probably had 50 travel agents 25 years ago. Now I think there was 3. So, okay. Now, enough on that discussion that there. Any comments on that there? Hopefully you found it interesting that there, but that there. Again, it has nothing to do with that there, but kind of an insight of what happened there. Okay, now let me talk about the Arduino. The Arduino is a small, and let me just go ahead and pull it out here. This is a small microcontroller board, not unlike the one used in, now I'm going to walk down here. It's not unlike the one that we used in the microprocessors and microcontroller course. The chip is a little bit smaller. I mean, it's a bigger chip because it's got the dip in it, but it's only got like 20 or 30 pins on it there. And this particular board is easier to connect to. This is called the Arduino Uno. I think I bought this for 100 ringgits. I tried one. I actually got it working. This is the one I managed to salvage it, but it has all the pinouts and easy connect, so we don't have to have somebody do that there. But this particular board is designed more for the hobbyist, not for the engineer. So that's there. But it's a good, easy board to see how we can control motors very quickly and easily. And this is what our robots use that we worked on last week, is they use that there. Now you wrote various commands. Now I'm going to kind of go through the commands that, and this worked in my office, it better work here. That's there. I plug it in the board, right there. So my board's plugged in, and again, it's very much like the 8051 board we use up there. Now, to control the Arduino, the robot, right there, we only have to set the pulse width to a certain pulse width. Now, we talked a little bit about that last time before that the Arduino actually has built into it something called servo.h right there. Right there. And the servo.h actually is a library that has all the various commands that there, and we have, and this one here is for the continuous. I don't want the continuous one yet. Yeah, I'll go ahead and run the continuous one out there. This one here, here, as you recall, if I set it to like 1800 pulse width, I get it to go in one direction. If I set 1100, it's supposed to stop, and I set it below 1500, or that there. And these don't look right, but commands that they're right there. For some reason, I was playing with these, but that's all right. You'll still get to see it turn in one direction, then the other, and continuously route that there. So it'll turn in one direction, stop, and then it'll turn in the other direction right there. So we got the clockwise to stop and the counterclockwise. Those numbers don't look right right there. And again, all we do is we hook up 3 wires that there. So every servo in that robot has 3 wires connected to it right there. 2 wires. The black goes to ground. The red goes to 5 volts. And the one other good thing I like about this is they put the voltages right there on the side to make it easy for us old men that can't see down in there to read that there. And I hook that to the black wire here. I'm going to leave the yellow out here. The black wire there. And the red wire right there. And then my pulse width goes to the white wire, which I don't have a white wire, I use the yellow wire. And that goes to pin 9. Now I can use pin 9 or pin 8 on this one right here. Right here. Now it's actually running. And then all I do is I just upload the code to it. This might have been the last one I was working on right there. Up. And tools. I got to reset the board before I could do that. And okay, servo does not have a type. Oh, I screwed up here. Open recent servo continuous. Uh-oh, what did I do? I broke it here. Somehow let me is that the one I want? Copy. Good. Cool. And cool. 8 right there. Okay, now it's working. And you can be my witness. It turns in one direction, turns in the other direction, then stops, right? And then it'll stop for a few minutes. That's right. So you can see that I'm easily controlling this, and I don't have to keep writing the program. It's in a loop, and it will work repeatedly and repeatedly right there. So it's going. Yeah, actually, I could put this on here to where it's easier to see, but right there. So, but that's our servo, continuous servo, and I can go through here and I can delete all this. And it'll just continuously run in one direction right there. Right there. Or I can go through here and I got that there. I can just put another my servo dot right microseconds. And I'm going to put 1300, for example, right there. Right there. And again, now it's going to do the rotate in one direction then the other. Right there, it just goes back and forth now. So it's a very easy way of controlling my servo. This is continuous. Now, when you see the way we control the normal servo, it's much easier yet because we just tell it the angle right there. So, close this. And this is another program right here. Now, this one here, all I'm going to do is I'm going to just simply tell it, I got a for loop right here. This is in C. And I go from angle from 0 degrees to 180 degrees. And I just increment the angle once right there, and I go up, and here I go back down from 180 to 0 again. And I got a delay of 15 to where you can see it there. Now that's for the normal servo, which is this motor right here. Right there, I happen to have. Unfortunately, they're wired the same, so it makes it very easy for me to sit up here and do a quick little demo right here, because I just plug these in. Now, it's probably not going to do anything until okay. It's going back and forth because I'm changing that there, but. And then this one, you don't have to verify it. People can see it from that there. But you can see, once it starts, see it's going around from 0 to 180, and then it goes back again, right there. Right there. And I can change the time to where it goes fast. Right there. Upload it. And I'll stop here a second. So it goes real slow that direction, then fast in this direction. I can make it go slower in here. Right here. So I can fast and then super slow. So I can control this motor very precisely. And this is actually the hardware that's used in our robot right there. And as you can see, we write those commands telling it to, to go to this particular motor and to set a certain degree, angle right there. And we tell it a speed initially right there. All the software that's in that board is taking our commands and changing them over to commands that look like this right there. So it's taking our MATLAB commands and just simply interpreting the commands and writing to the motor. So if we were to write to the servo motors directly, our code would look more like this right here, right there. And as you look, this is a typical C program, right? Right there. This is a typical C program. There. Now, some of you might not have remembered C since the last time you used it. Right there. But we have it include servo.h. It has the libraries. So that particular library knows what to do when it sees the command servo.right and it receives an angle right there. So it knows what to do if we do servo attach servo pin. That tells this command right here tells the software that we have a servo motor attached to pin 9 right there. If I wanted to attach it to pin 8, I can just tell it pin 8 right there. And if I look on this particular board, I've got about 6 different motors or 6 different pins I can attach servos, which, by the way, is the magic number that's in our robots, right? There happens to be 6 robot servo pins on the Arduino board, and our robots have got 6 motors in them right there. But a key thing, you know, now that we're done with the political stuff, is just to show how easy it is to do what these robots do right there. You know, again, all the intelligence is in this command, this library called servo.h, but we don't need to worry about that. All we need to know is if we do servo right, dot right, and give it an angle, it's going to turn that motor to that angle right there. Well, unfortunately, we can't get into those motors and control them directly like I would like to in a microcontroller class out there. But this is kind of an extension of our microcontroller course that there, as we look at how these servos are controlled in that robot. We're using a typical, very low-cost microcontroller out there. And as I said, I'll just pass this around and see how easy it is to wire this up. So just don't worry, don't break it. You break it, I got 2 more stairs I want. That there. But you just see it's just 3 wires. VCC ground and a control wire. Right there. And it's very easy to control that there. So when we look at controlling a robot, that there, we really have got 2 things that we're going to write to the robot. Is that one was we write which motor, and that's between 0 and 5, right? We have 5 motors, and then we have an angle right there, and that's between 0 and 180, right? That there, and those are the only 2 variables that we have. In this case, this example, I only had 1 motor, so right there. But again, we would have in our code, we'd have, going back to our code here, right here, we have this servo pin 9 right there. We would have here we have our setup here, servo attach right there. We would have 6 different servo pins. Servo pin 0, servo pin 1, servo 1. And we would do servo dot attach servo pin that there. Again, we would have to attach all those right there. But here at servo, we specify which servo it is. Now, servo, uppercase servo is a type. Lowercase servo is a variable name. Now, that's a little tricky when you look at this code, because so I could have servo 0, servo 1, servo 2, servo 3, just simply by saying here, if I want to put 2 servos on here, I can do int servo pin 2 equals 8, right there, and then I can turn right around here, and I could do servo 2 right there, and then I would put in here servo dot attach, and excuse me here, servo 2 dot attach dot servo pin 2 right there. So now I've attached a second servo to pin 9, and I call it servo 1. So then what I could do here is I could, and I didn't bring it, I should have brought a separate servo motor to show this, but I could have one servo go in one direction and another servo going in another direction, for example, right there. So I could then turn right around here, and here my angle is between 0 and 180, so I can simply say servo 2 dot right 180 minus angle right there, and same thing here, servo right, and I'll seal that back, and 180 minus angle right there. Right there, that's going to go in the reverse direction, and I'm just going to simply show that one's going to, it's not going to look very different, to be honest with it, but it'll go in one direction. Well, it will work different because I've got it at different speeds. So you'll see, if I go in one direction, if I flip it from pin 9 to pin 8, the other direction will go at a different speed right there. So I'm going to steal that back and just kind of show this demo here. Go ahead and take a look at how the guys look at it. Very, very simple here. as I'm running the demo here, I'm just going to move this from pin 8 to pin 9, right there. And you'll see that, and I'm not going to risk burning this up by hooking up a power supply to it. Right there. Right there, so, right there, I mean, oh, servo 2, oh, actually, that should just be servo attach. Right there. Okay, servo. Doesn't have a class type right there. Okay, I'm missing something. You're seeing it up there. Oh, servo pin 2. Servo dot attach, servo dot attach. Okay, servo pin. Let's make sure it's in that particular place right there. But I still need to attach the pin. Yeah, see that there? I still need to attach the pin right there. So servo. There was a no. All right. What? There's a space right there. Let's go through here. Oh. Okay. Now I see what you're trying to tell me. Yeah. I can look at this for 15 minutes and not see that there. I put a dot in that there. Okay. Yeah, there. Now we can download it right there. Okay. Now it's going very. Okay. Why did it stop? It shouldn't stop. Then compile it.
You're missing something. So you're missing the close bracket.
All right, I didn't do anything to break it, but there.
Is it supposed to the attach?
Yeah, well, I attached this one here. Let's move this to pin 8. Pin 8 is working. Oh, you know what I'm doing here wrong? I forgot the 2 here. That there. That's what I did wrong, that there. When I was trying to fix it, I broke the wrong thing. I broke something else, which is always the case, right? So now it goes very slowly to the right and very quickly to the left. I move it back to pin 9. It goes very slowly to the left. So and there, if I had a second motor, you could see that they would go in opposite directions right there. But unfortunately, I don't have my second motor with me right there. I do have a second motor upstairs. I'm not going to bring it for another demo. This is my last of the servo demos right there. Right there. So unfortunately, I don't have a camera on so you can see it. But again, you can see that it's going slowly to the right. And then if I move it over to pin 8, it goes slowly in the opposite direction right there. That's pin 8. And this is pin 9. So it just reverses which direction it's goes right there. But again, what's going on here is I'm writing one angle to one motor here. And no, actually I'm not. this one here is, actually it should have been doing some funky things there. Now it's going slowly in that direction. Now it goes slowly in the other direction up there. So it's working now. Now that I got the serval 2s straight. You should never write code in front of a group of people in a class with a headache. Right there, but it is working exactly the way it is supposed to be right there. So I'm going to stop here at this point. You guys go ahead and look at it while I'm tearing it down. You can see there's not much to see. There's just 3 wires between the board. It's relatively simple. If I had 20 boards, I'd just make you go do it. But unfortunately, I got 3 working boards right there, and only 2 motors right there. So with that said, and I still talked an hour.